you have this. This is a small circle. This is a small circle, and this is a great circle. A small circle is found along the parallel of latitude. It's found on the latitude, while the great circle is found on the longitude. The great circle is found on the longitude. Then you have small circle. All circles on a sphere of radius r whose center and radii do not pass through the center x of the sphere are small circle. Exactly. So you have your center x. It does not pass. Small circle does not pass. A small circle does not pass through the center x. It's only a great circle that has the tendency to pass through the center x, and that is the major difference between the two, because the great circle, you have it passing through the center x, so it is formed on the longitude, while small circle does not pass through center x, and you have it on the latitude. That is the major difference between a small circle and a great circle. Angles between 2 points on the Earth's surface can be justified by saying, when you have angles between 2 points on the longitude denoted by long, when the points are in the same direction, we subtract. When the points are on or are in the same direction, the same direction, we subtract. Then 2, when the points are in opposite direction, we add. What am I saying? To give a substantial example to justify my claim. Example, let's say you have a point P and you have a longitude of 108 or 105 west. You have 105 west. And you also have, let's say, Q. You have 45, or let me say 75 degree. So let's say 75 is on 75 degree west, and let's say 75 degree east, for example. If you look at this very well, you discover that they are in opposite direction. So it will be P plus Q. Then that will be 105 plus 75. So the angle between them, which is theta, will definitely be 180 degrees. That is, this one is justifying the first. No, this one is justifying the second case. It's justifying this, the one you have two, when the points are in opposite direction. So you have your hat to get your theta. But if they are in the same direction, let's say '85 degree west, let's say P, 85 degree west, and you also have Q, 42 degree west, in the same direction this way. So what we are meant to do is to subtract. So we have P minus Q. Our theta, P minus Q, will definitely be 85 minus 42. And that will be 4. That's 43 degrees. So the theta there will definitely be 43 degrees. degrees. These are the simple concepts that are applicable as far as longitude and latitude are concerned. Radius of the Earth's surface and radius of parallel of latitude. You have this as the sphere. Then we have our equator. Then we have our parallel of latitude. This is r, small r, because why is it small r? Because it's along the parallel of latitude. That is why we have it as small r. Then if you have our greenish meridian like this, we can determine this. This point is a radius because a line drawn from the center to meet the circumference is radius. But this time around, since it's along the longitude, it's going to be capital R. Then this is our alpha. So what we are trying to do here is to deduce a relationship between radius along the parallel of latitude and radius on the great circle, that is the radius on the longitude. So if you look at this very well, we have a right angle triangle here, so we can apply Pythagoras theorem. And by applying Pythagoras theorem, we can definitely say that cos. Why do we need to choose cos? Because we have adjacent and we have our hypotenuse. And remember, Sokatwa Ka is talking about adjacent hypotenuse. That is why I've chosen cos in preference to others. So we have cos alpha will definitely be adjacent R over hypotenuse capital R. Then when we cross multiply this, we have our R to be equals to R cos lat. So this is a very fundamental formula in longitude and latitude. At any point along the parallel of latitude, our radius is equal to capital R cos alpha, where R is the radius along the parallel of latitude, the R is the radius along the longitude, while alpha is the angle, that is the angle of the latitude. So sometimes they use this alpha interchangeably with lat. So I can say R equals to R cos lat sometimes, but I don't want to put alpha. So you can use alpha and lat interchangeably. So let's see some examples to justify the concept of what we have discussed. Example 1 and example 2 are shown in figure 1.1a. So this is figure 1.1a. Now, find the radius of the parallel of latitude. That is what this question asks us. So the solution to example 1. Solution. It has to find the radius of the parallel of latitude. So since we have to find the radius of the parallel of latitude, remember that the formula is R equals to R cos alpha. That's the formula. Now for the first case, we have Q 63 degree north, 72 degree west. When a point like this is given to you, you don't need the longitude. The longitude is just given to you to distract your attention. So what you really need is, you know, your R to be 6,400. It will definitely be given to you because it's a constant. Then your alpha is also known to be 63 degree. So your alpha is 63 degree north. So it will also be given to you. So here we have R to be equals to R cos alpha. Then our R will definitely be 6,400 cos 63. So your R will definitely be, what is cos 63? Cos 63, then we multiply by 6,400. So that will give us 2,905 kilometers. So this is 2,905.5 kilometers. That is our R. For the second question, this is the A. For the B part, we have 36 degrees south. So we also apply the same formula. R equals to R cos lat, cos alpha. Then R equals to 6,400 times cos 36. Cos 36 times 6,400. Then we'll have 5,177.7 kilometers. That is what we are going to get. So example 2. Find the radius of a parallel of latitude of P. So automatically this one is also the same as the one in example 1A. Here we have R equals to R cos alpha.